Joseph Scott is visiting us today from the far-off land of Salt Lake City, Utah. Joseph is from here. He's one of the very early employees of Automatic, has been there for a long time. He works on the performance team there now, and the level of projects that they're doing everything at scale, and so just a wealth of knowledge for things around performance. He's going to talk about performance and how to measure it today. So welcome, Joseph Scott.
My name is Joseph Scott. I lead the performance group at Automatic. This is going to be a little bit of a roller coaster ride. I'm going to cover a lot of different topics lightly and very quickly. So that's going to be the roller coaster that you're used to herky-jerky back and forth on those turns. All right, so let's jump in. This is probably a saying you've heard more than once, and it's been around the block, but it's still very true today. Performance is a feature. The question is, how do we treat that feature, right? Oftentimes, it's a feature that gets left out in terms of our planning, our thought process, and actually making sure that it works. How many have heard this? The site is too slow, all right? That's great. Like, I get these reports. I get them all the time, right? Somebody comes to me and says, the site is too slow. And the problem is, that's nice to know, but that complaint is completely unactionable. There's not enough information for me to know what to do. So where do we go from there? So the site doesn't work. Who's heard this? All right, as developers, right, you've probably heard this, and you probably have the same response that I did to the previous comment, right? The site doesn't work. Well, that's great. What doesn't work? This is like you've inched, but you haven't given me enough information to actually take action on. So here is what I want to get across. Treat performance like a bug report, right? And as developers, unless you have mastered the art of writing bug-free code, right, you've probably had a bug report, and you've probably had a bad bug report. Hopefully, you've also had good bug reports. But what does a good bug report look like, right? Because, again, the site doesn't work. I need more information. So a good bug report, right, we're talking about precise details. We need to know what you did, what happened, and what you expected to happen. So I need to be able to reproduce it. I need all of the environment details. Does it only happen in one browser? Does it only happen on one computer? Does it only happen in one connection? I need all of these details to determine what's going on. All right? Treat performance like a bug report. You need to have that same level of rigor that you apply to your bug reports that you apply to your performance complaints. So when somebody says, hey, the site is too slow on my mobile device, all right? You're probably, if you haven't gotten that complaint yet, you probably will, all right? They'll say, hey, it works great on my desktop, on my Google Fiber connection, where I get 1 gigabit up and down, which I don't have, by the way. Yes, thank you. Sad note, right? They did it. Okay, so here's the deal, right? They do it in Provo, south of me, in Sandy, and they do it in Salt Lake, north of me, and I'm like, just fill in the gaps. Anyway, so they say, the mobile, okay, it doesn't work. That's great. So let's go back to this bug report mentality, right? We need more data. And they'll say, well, I'm staring at my phone. I can't really get much data for you from that. So they'll go back to their desktop, and if you're lucky, right, they'll know about the network inspector. And if you're really lucky, that will have enough information for you to figure out what's going on. Odds are it won't, but sometimes you get lucky. And if they're really good, they'll know, Chrome can emulate a mobile device. So I'll turn that on. Good. Next step, they know, I'm on Wi-Fi, though, and my mobile device, when I'm out running around, it's usually not on Wi-Fi, it's on something else. So I can throttle the network connection in Chrome, right? If they've gotten to this point, then at least they know what's going on. Then they go, this is a small phone, and the CPUs are very different than my laptop, my 8-core monster, whatever thing. So I will throttle the CPU, and that will mimic my mobile device, right? If you've how many people have gotten to this feature level, right? A couple people? Oh, actually, good. This is great. Like, if you get a report that has this sort of information, all right, you've got somebody who's really interested in making this work. That's good, but honestly, it's not good enough. All right, let's take a real mobile device, right? We've got some nice specs. That's a Moto G4. It's been out less than a year. It's not necessarily top of the line, but it's a decent phone. And there's great instructions on how to connect that to Chrome on your laptop, and you can go through all those same steps and actually get useful data out of it. Here's what you learn, though, is that life is very different between the two. There are and I won't go into the reasons, but there's a long list. Basically, here's what happens. Mobile phones hate you. And I'm not saying this. This comes from Alex Russell, a Google Chrome developer at Google, right? So it's good if you can say, hey, I've got a mobile phone. I plugged it in. I'm using a real device, and I'm collecting good data, all right? That's also good, but honestly, it's not good enough in terms of long-term measurements. It's very difficult to sit there and say, okay, I'm always going to use this phone under the exact same conditions. And that's really what we have to get to. We have to start thinking more scientifically about our measurements processes. There's kind of a general set of principles that I dig into in terms of setting goals. You need to measure before and after. You need to make one change at a time. All these things that you would normally do in good development processes that you might apply to a bug report, you need to be really rigorous about applying to your performance measurements. So here's what will happen, right? Somebody will come up and say, I have a goal. I want this in 3 seconds. This is about as useful as the site is slow. 3 seconds what? Right? I need more data. And that's often what ends up happening. It becomes your problem in terms of web measurements, is you need more data to make good decisions. All right, so when we talk about a goal, like, I need a laundry list. Again, going back to this think scientifically idea, I need details so that I can reproduce it consistently over time. So here's just an example of a goal you might have. All right, now somebody will say, okay, that's great. How do I make that goal? What should I do? Now, a lot of times people will go, I will go to the source of all truth. I will go to Google. And they produce wonderful information. DoubleClick, which is an ad network that's owned by Google, came up with this amazing performance report. And this is one of the things they said. 3 out of 4 mobile sites take longer than 10 seconds to load, and the average time is 19 seconds. Asterisk! Right? Now, if you're me and you think about web performance all the time, you're going, what the heck's the asterisk? I want it. This is nice, but it's still not enough data. What's the asterisk mean? Oh, well, we ran this through webpagetest.org. We ran almost 12,000 sites and fast 3G. All right? Okay, that's a little more information, but it's still not really enough to know what's going on. Right? I read this and I go, well, what exact URLs did you test? What is the metric? You said it's seconds of what? That doesn't help me. What operating system? And the last one I love, what the heck is fast 3G? All right, I don't know about you, but fast 3G is like a rare beast. So this goes back to this idea of consistency. We need a controlled environment where we say, this is what's happening over and over and over so that we know how to impact it. And measuring before and after, right? So I've talked to developers where they say, hey, I got a report that a site was slow. I did these 12 changes, and then I went and measured it, and it's pretty fast. And I'm like, okay, what was it before? I don't know. Well, you can't just measure after and expect that things are going to be great. Measurements are things that you have to do over time and make those changes one at a time. So, hopefully this is going to spark a question. What can I do today? All right. I'm going to throw out some suggestions. There's lots of other things, so take mine with whatever sufficient grain of salt you feel you need to have with my suggestions. But the first one I'm going to say is web page test. This is a public service. It's a great site, and it provides you oodles of data. It's open source, and it's got test agents around the globe, and it does a unique thing. Excuse me. It actually has real mobile devices in their Virginia location that you can run tests from. And there's nothing quite like a real mobile device. It's difficult to do, but you can do it. So anybody can use this. You can go to webpagetest.org and try it out. I'm not going to dive into the details because using a tool like this is an entire talk unto itself. For those of you who want something a little more pre-built that you can just go and pay for and get good data and graphs and trending, I recommend something like SpeedCurve. Again, there's 1,000,001 different services out there, but this is a good one to choose. It's built on top of web page test. Again, it's open source, so they have their own infrastructure where they're running private instances of web page test and then trending that data over time. It's run by a couple of folks, one of whom is Steve Souders, who is basically the godfather of web performance. If Steve Souders writes it, you should read it. And for SpeedCurve, they have a nice blog. Even if you don't use their service, I highly recommend subscribing to their blog. They have some great details on the sort of things they're looking at and the sort of things that they're tracking over time. Another nice aspect is that web page test being open source, you can go and run your own private instance today. That's something that we do at Automatic is we have 11, 12 different test agents around the globe that all report back to our internal web page test setup. One word of warning, if you're going to go this route, they have something that makes it really easy. They have EC2 images, so you can spin up a test agent wherever their EC2 is available, which is really nice. However, some of the EC2 instances are really underpowered. What I found is that the lower end ones will actually max out on CPU just negotiating HTTPS. So that's, for me, that's like my threshold of underpowered, is if I have max out the CPU just negotiating encryption between you and me, then you're not up to par. There's a lot of really nice features in web page test that enable you to do things with a lower amount of impact developer-wise. So for instance, blocking requests, which is really nice. So you might have an existing page and go, well, what would this page look like without this ad network loading on it, right? You don't even have to edit the page. You can run the test again and just say, block that host name. And then you can do the comparison. It's really nice. Single point of failure, the idea where you might have a third-party piece of code and their server's down or a piece of fiber got cut and we can no longer load that third-party piece of code and it just hangs. Well, what's the impact of that on your site, right? It might be really bad. Who knows? They have a little scripting language that you can use to run these various tests, which is really nice for doing things like login forms. So you might want to test a logged in experience. You can actually tell web page test, go through the form, fill it out, and then go to this other page and let's do the measurement. My most common use for scripting is for logged in results. Packet capture. Now, unless you're really a network geek, you may sound a little intimidated, but if you run into a network failure or oddity, your network operations folks are really going to love the packet capture feature. I ended up using this at some point to confirm a TCP bug in Nginx's HTTP2 implementation. There was a series of like 6 conditions that had to be met, and then it would slow down by like 5 times what it should have because they weren't setting a TCP flag correctly. And the only way I could confirm that was actually going through the raw packet dump to see the headers of each packet. So here's an example. Let's see if this plays. So when you run a single point of failure test, it will actually do the comparison for you. And one of the nice things that I highly recommend is it'll generate a video. And when you're talking to other people, like if you run all these tests and you're going to generate a high-level report of what the results were, I love the video comparison because it drives it home so well. So here's what I did is I took a site that happened to use Google Fonts. So it was remote loading from Google servers and said, okay, black hole, Google Fonts as a single point of failure, and let's see what the page load looks like. So it gives you a nice little counter, and as soon as it'll come up, it'll show the difference. And this is such a nice visual. You might know this site. So this is how it loads normally. This is what happens if Google Fonts is down. Now, Google Fonts probably isn't down very often. But you can just see, right? It gives you that almost tangible experience of going, here's what happens when a failure condition hits us, right? Now, this doesn't look too bad, right? It's about 50% slower, right? The reason for that is Google Chrome changed their policy. They used to sit on a Google font, a font request until it timed out at like 300 seconds. Right? What they realized is, hey, sometimes people load fonts and it fails. And they said, instead of waiting like 300 seconds, why don't we wait like 3? So this used to be much worse, but it's better now. So another aspect that comes up that people like to talk about is what to measure, right? We went back to the I want it in 3 seconds, all right? 3 seconds of what? How do I measure that? So I'm going to give some recommendations and take them with the necessary grain of salt that you feel, but these are the ones that for me, if I had to pick just a handful, become really important. The first one is speed index, and this is unique to web page test. I'm not aware of anybody else implementing it currently. But basically the idea is every 100 milliseconds, it takes a screenshot of the viewport on the browser. And then it runs through each one and goes, okay, how many pixels changed between this 100 milliseconds and this 100 milliseconds? And it'll do that until all the pixels have shown up on the page. And it basically gives you a calculated number, a score, based on the pixel rendering over time. There's some actual math and calculus involved. If you're not into that, I recommend the second link here. There's a nice, good description with bar charts and things like that of how speed index works. But it gives you a nice calculated score. The difference, the one concern is it's not a measurement per se. It is a calculated score. But if you had to pick one stat, that would be the one I would recommend, mostly because it mimics the user experience the best. Because what it's calculating is what the user is going to see over time. The next one I would pick is time to first byte. And I want to clarify what I mean by this. I mean the time between the TCP and DNS, TCP, HTTPS, all that other stuff being done, so the connection's open, and the first byte coming back from the server. All right, so there's this little window of time. Hopefully it's a little window of time. Hopefully it's not a big window of time. Where you're waiting for a byte to come back, even though you've made all the network connections and everything set up. In theory, as long as you don't have some horrible network condition, in theory, that is the time that it takes. It's mostly the time that it takes the server to do work to send data back. If it's a static file, it should just be reading it off storage and sending it out. If it's a complex page that's logged in, it might be making memcache calls and database calls and all these other things. That gives you that measurement. Also, you could potentially do this measurement for every single request. When I refer to time to first byte, I mean that first request. Okay, the initial page request and only that request. Because nothing else on the page can happen until that is done. So if that's a problem, there's nothing you can do afterwards to make up for it, right? If your time to first byte is already 5 seconds, right? Concatenating your JavaScript is not going to improve that 5 seconds. You've already eaten it. Nothing you can do afterwards. So that's why this is my next on my list. The next would be start render, because as soon as you go and tell the browser, hey, I want to load this page, it goes blank. And you can think of that as the price everybody pays for a loading screen, right? And what if your site already has one, right? So you're actually telling the user, okay, you've got a blank page, and then I'm showing you a spinner, and then I'm doing this other stuff. So start render. And basically, it can only be even 1 pixel, and web page test will pick that up. And it's a nice measurement for going, when does the user start to see something? Now, a caveat to this. It doesn't care what pixel it is, all right? Not all content is created the same. So keep that in mind. You might notice that the first thing your page renders is not really that important, and the more important stuff comes and renders later. The next sort of measurements I look at are fully loaded and bytes. And the reason for that is you get things like onload events and doc complete and all these other things that historically we've measured pretty well. But now we're so good at loading stuff asynchronous and doing other things on the side that those are not necessarily helpful metrics in terms of what the user is experiencing. So fully loaded, basically, from the point of view of web page test means, hey, I've been tracking all of this and there's no network activity for 2 seconds, so I'm going to consider the page done. The reason bytes I include in there is because I've had sites, mobile sites, where they get like a really good speed index, 1,500 or less, but they're loading 17 megabytes on a mobile page. So that's why I'm giving multiple metrics. If you had to pick one, it's speed index, but there's multiple things going on. And if you're sending 17 megabytes to load a mobile web page, then you're making your users suffer. One more thing I'm going to talk about, and this is not a measurement per se in terms of a general statistic, but there's a wonderful API in modern browsers now called user timing. Gives you basically high resolution timestamping between events. And this allows you to say, hey, I care about this particular action in the page, so I'm going to benchmark that. And web page test can go in and pull all of those marks that you've made to indicate what you care about. And this basically, when I said it doesn't care which pixel it is, this is how you can decide which pixels are important. Okay, so that's a really useful API to get into. Now, all of the things I've talked about are basically synthetic testing. There's a whole world of real user measurement, and basically by definition, that's a piece of JavaScript that sits on the page and looks at what the user experience is, and then reports that data back. There's a whole bunch of services, again, kind of the same sort of realm of synthetic testing. There's a lot of services that do this. SpeedCurve offers one, as well as Sosta, who has a piece of code called Boomerang, which originally came from Yahoo. Companies bought other companies, and it ended up there. It's if you want to do this on your own, if you want to do some real user measurements on your own, Boomerang is a great piece of client code to start with. And it basically gathers that data and sends it back. Now, at the risk of sounding like clickbait, there's kind of a way to cheat, all right, when you're looking at goals and performance measurements and stuff like that. And it's a way that I highly recommend. So let's start with a goal, right? We've said this is the type of goal we want, and we're on 3G, and these are the characteristics of this 3G. We're being very explicit. And But basically, the main one is I want the time to first byte in less than 100 milliseconds. Okay? Here's how you do it. You say, screw all that and put it under ideal conditions. All right? And by that, I mean, we're not doing 3G. We're going to pretend we're like in the same data center. And we're not going to do it in Oregon because the server's in Virginia. We're going to test like in Virginia. You're going to test under the ideal circumstances. And the reason for that is if you can't meet your target in ideal circumstances, then you're never going to meet your target. You have to go back and start over and change your assumptions and rework the system. So this is a really great way. So if you have a manager or developer comes to you and says, hey, I want to load this mobile page and under this time and that, fine, that's great. Let's start with that by throwing it all away and doing it under ideal conditions on a desktop, right? So the Virginia EC2 location is 1 millisecond away from a data center that we operate. And that's how I do this. Because if I can't get it to work from a data center that's a millisecond away, there's no way it's going to work on 3G or LTE or any mobile condition. So that's my policy there, is throw those away and do it under ideal conditions. A couple more suggestions. Keep your raw data over time. I mentioned web page test, and many of these other services will generate reams and reams of data. And you'll be tempted to say, you know what, I only need it for 30 days, I only need it for 2 weeks. You can throw it away after that. I've trended my graph, and I'm done. Let me suggest a good reason for not doing that. So this is a test. This is a graph from one of our test locations in India. And there's a lot going on, but the big thing is, what the heck happened here? Right? We were doing really well. This happens to be the speed index score. We were doing really well, and all of a sudden it went way up here. What was going on? Now, because of timing, I happened to not notice this for 3 weeks. And I went back through all the raw data. I went and I took a web page test, because that's where this data came from, before and after, and did all the comparisons and looped through that. And what I discovered is that it was routing requests from India to a different data center. Originally, the before is when it would route to Singapore, and the after was when it would route to Hong Kong. Now, I didn't really realize that was a big deal, right? All kind of in the same region. But it turns out that there is a large fiber connection from the east end of India directly to Singapore, and it was cut. And so the routes had changed. The only reason I noticed that was because I kept all the raw data, and when I saw the thing on the graph, I was able to go back and analyze what the heck had happened. Let me talk a minute about stats. Again, this is kind of a herky-jerky turn here, but there's a common saying you might have heard: there's lies, lies, and stats. Funny thing, and actually I think Mark Twain's description was lies, damn lies, and statistics. And Mark Twain was quoting somebody, claimed to be quoting somebody who never actually said it. So it's a little bit of a loop on itself. If you're into this sort of thing, I highly recommend a paper by Kerry Millsap called Thinking Clearly About Performance. It's a PDF at this URL. It's about 15 pages. There's a little bit of math, but it's not too bad, and it's really quick reading. And he had been doing Oracle database tuning for years, and so he had thought a lot about this methodology in terms of dealing with performance and statistics. So I'm going to steal one of his examples. Let's pretend that each side of this is 2 different sets of response times, okay? Now, on this side, the average happens to be 1, okay? Now, what if I told you the average on the second side is also 1? Which would you prefer? Okay? My lesson here is that averages can lie by hiding data, right? Average is a really tempting metric to use because it's easy to calculate. Everybody knows how to calculate an average, right? And sometimes that's appropriate. as long as you're aware that it can lie to you about the data. So for instance, one important piece of this is that the ranges are completely different. And one point I will make out is that consistency has a really high value. For this, I would actually take the smaller range, even though, right, if you look down here, the slowest time was actually worse, and all these numbers, like the fastest is, I would take the consistency over the wider range any day of the week. And the reason is, if I make an improvement to that item that is consistent, it will drop all of them. Right? You improve the other side, which has a wide spectrum, you don't know where that's going to improve. So you have averages, consider other things. Consider ranges. A big thing is percentiles. Median is a really popular one. Again, that tells you, okay, I'm in halfway. So half the people are getting something faster, half the people are getting something slower. You might want to bump that up to 90, 95%, 99%. But at least with that number, you know where you are in the user experience. In averages, again, that information can be hidden. My time is coming up, so let me say one more thing, because this came up a lot at the speaker dinner. I added this like 10 minutes ago. HTTP2 is new, and you have to make less assumptions about it and more measurements. There's just, the implementations are young. There's more variables going on than there ever was before. So it's generally a good thing, but you have to measure more and make fewer assumptions. For things like domain sharding came up in a conversation. It's like, well, yeah, sort of. So that is my litany of things that I'm going to throw at you. But my takeaways are, performance complaints are bug reports. Your developers are used to dealing with bug reports and making them really rigorous. My suggestion is to do the same with your performance reports and test in a controlled environment. Be really specific, do it over time, and keep all that raw data. Be really precise. Again, thinking scientifically, we want to make them reproducible. Now, one thing I want to say is, the good news is it feels like we're entering the golden age of web performance measurements. Never before have so many people been really interested and motivated to improve things. So that's my takeaway. My name is Joseph Scott, and if you want to chat later, please come talk to me.